Good afternoon, everybody. As I said in class today, that I'm super excited that we're starting this stoichiometry chapter. It leads us to areas of chemistry that I really enjoy, and hopefully you will too. And so this chapter is going to take a little bit of work on your part, and hopefully you won't become too frustrated. And if you do, make sure you're coming in and getting some help. So the first thing we're going to do is going to do some mass calculations, which is going to build on the mole-to-mole relationship that we did yesterday in class. So write and balance a combustion equation for the equation of propane. So we actually wrote this one in class today, C3H8 plus 5O2 yields 3 moles of carbon dioxide plus 4 moles of water. So as we talked about today, make sure that you go back and read exactly what's given in the problem. So it says what mass of oxygen, so we're looking for grams of oxygen, so put that in here, X grams of oxygen, will be required to react exactly with 41.1 grams of propane, sorry. 44.1 grams. I just got done eating. Can you tell? I'm thinking about food. Propane, not protein. Okay, so now if we take a look, I'm going to do a little mole map. And what we want to do is we want to figure out exactly how many grams of oxygen I need to react with 44.1 grams of propane. So I'm going to take my grams of propane, I'm going to convert it to moles. So you should be looking at your mole map and taking a look at what that means. We are going to need the molar mass. And then I'm going to be able to get and do my mole-to-mole relationship, unknown over known, to get to moles of oxygen. And then I'm going to go to grams of oxygen. Okay, so this is my little roadmap. This is how I'm going to get there, sort of like our GPS of our stoichiometry equation. So I'm going to go from grams to moles. So I always go back and start with what's given, 44.1 grams of my propane, time sign fraction bar, like we talked about. So now I'm going to do molar mass. I'm going to go from grams to moles. Well, I know that in 1 mole of my propane, I do the molar mass. I'm going to add 3 carbons, which is 3 times 12.0. I'm going to do 8 hydrogen, which is 8 times 1.0. Hopefully, you know I'm getting those numbers from the periodic chart. Add that all up, and I get 44.0 grams. So right now, my answer is in moles of propane. So I need to keep going, time sign fraction bar. Now we're going to do our unknown over known, those keywords that we've been talking about. So how many moles of my unknown? 5. And how many moles of my known, because that's where I started, was 1. So 5O2 to 1 propane. And then I want to continue to make sure my units are canceling out. I have grams on top, grams on the bottom, moles on top, moles on bottom. So right now I'm in moles of oxygen. So it looks like I need to do one more conversion from moles to grams. Look at your mole map and it says I need to multiply by the molar mass. Well, the molar mass of one oxygen is 16 times 2 is 32.0 grams of oxygen in 1 mole. And then I can see that my moles are going to cancel out of oxygen, and I'm left with grams of oxygen, which is what I want because that was my X. So I'm going to take, excuse me, take my calculator, look at this, is like 44.1 over 1. So I multiply all the way across the top, 44.1 times 5 times 32 divided by 44, and I need 3 significant figures, so the answer is 160. I need to put the decimal point behind that for 3 significant figures, grams of oxygen. So what this means, you guys, is that I'm going to go back in lab, I'm going to measure out 44.1 grams of propane, add it to 160 grams of oxygen, and my reaction is going to go to full completion. So the basic steps to follow, like it says on the next slide, is we write the balanced equation. We determine the known and unknown by reading the problem. Write out the mathematical equation using dimensional analysis. Remember, here's my mole-to-mole ratio, unknown over known. Find the unknown. Do your math, label, significant figures, all that good stuff. All right, so if you want to take a look at your book, this is the question I'm going to find. And it's talking about hydrofluoric or hydrogen fluoride and sand and trying to get it to react to make silicon tetrafluoride and water. So I'm just going to quickly write down the balanced equation. We need 4 moles of HF plus 1 mole of silicon dioxide is going to give us 1 mole of silicon tetrafluoride plus 2 moles of water. Okay, go back and read the problem, and the problem is asking for the grams of hydrogen fluoride, and we are starting with 5.68 grams of silicon dioxide. So my mole map, I'm going to do the same thing. So I'm going to start with grams of silicon dioxide because that's what's given. I'm always going to take my grams and change it into moles. Then to compare silicon dioxide to hydrofluoric acid, I have to do my mole to mole ratio. So that will be moles of hydrogen fluoride. And then I'm going to finally get 2 grams of hydrogen fluoride. Okay, so 1 second. My gosh. Am I not recording? Okay, sorry, couldn't find it. Yes. Okay. Let's see, you're in 3rd hour, right? You know, maybe once you get to the back, you can just wait until if you want to pull them out. Huh? Yeah. You'll need it on the back. Okay. That I can handle. Not. Oh. Oh. Gotcha. All right. I'm going to be chatting away. Oh, I think everyone just heard our conversation. Sorry about that, you guys. I was helping Annika with a test. You could have fast forwarded right through that. Yeah, it is recording. Okay, let me finish. I don't want to start over. Okay, so here's my mole map, grams to moles to moles to grams. And now I'm going to go ahead and plug in all of my numbers. So remember that we go back to what hello is started. And 1 second. I had to hit play. All right, I just had another interruption, so hopefully we can start back from where I left off. So we have our mole map here, and we are going to go from grams to moles to moles to grams. So the first thing you need to do is we need the molar mass of silicon dioxide, so 1 silicon and 2 oxygen, and if you add that up, you get 60.1 grams in 1 mole of silicon dioxide. All right, so time sign fraction bar, I need to do another conversion. I'm going to do my mole to mole ratio now. So the Q word's unknown over known. So I look up and I see that I have my unknown. I have 4 moles of HF to 1 mole of my silicon dioxide. Okay, so I have 4 moles of HF to 1 mole of my silicon dioxide. And my last step is I need the molar mass of HF, which is going to be 20.0 grams in 1 mole. Okay, let's check our units. You guys can see that I have grams on top, grams on bottom, moles of silicon dioxide with moles of silicon dioxide, moles of HF, canceling with moles of HF here. So you need to grab your calculator now, and you're going to take 5.68 times 4 times 20, and then divide it by 60.1. Can't forget about our significant figures, so when I go back and look, I have 5.68, which is 3 significant figures, so my answer is 7.56 grams of hydrogen fluoride. All right, so that is this first part of stoichiometry. Thank you for bearing with me with all these interruptions. So now what I'm going to do is I'm going to do another recording and do a couple problems on homework 1. So if you want to follow along with that, great. Or if you want to try it first and then go ahead and listen to that podcast, I'll do a couple example problems for you. Good luck and have a wonderful night, and I will see you in class soon.